to section 12.4, solving quadratics by graphing. For the bell ringer today, we want to go to desmos.com and graph these two functions. And then we're looking to find where our graphs hit the x-axis, looking for the x-intercepts. So you want to pause the video and go ahead and do that. Okay, so you should have a y-intercept of -3, which means it hits my x-axis at negative or positive 1.5. And for the quadratic, looks like we hit at -1 and 4 on the x-axis. So section 12.4, we're solving quadratics. We're going to do it by graphing today. And we're also going to solve some specific quadratics by taking the square roots. And I'll show you what I mean here in a bit. If you recall, the standard form of a quadratic looks like ax squared plus bx plus c, and it's an equation now, so it equals 0. A can't be 0, of course, because then that would make it linear. The solutions, so what we're looking for when we're graphing quadratics are what we call the zeros. That's where your parabola hits the x-axis. You're looking for the x-intercepts, aka the zeros. And a quadratic can have 1, 2, or no solutions. Examples: the basic quadratic, the parent function, x squared equals 0, where the vertex is at the origin. Well, since the vertex is on the x-axis, that means that there is only one solution. If we shifted that down 4 and it's still facing upwards or opening up, you can see that it hits the x-axis in 2 locations. So this would be a situation where there are 2 solutions. And then a no solution situation would be one like this one that's shifted up, still facing up, so it doesn't hit the x-axis anywhere. So if you're actually looking for what the solutions are, you can see that this particular example has 2 solutions at 1, -2, and -3. This example hits the x-axis at x equals 3 and x equals 4. So the solutions would be 3 or 4, 3 and 4. We call those the zeros. Here we have x equals 1 and x equals 3. And this is a case where the vertex is on the x-axis, so there's only one solution at x equals -4. This case doesn't hit anywhere, so we would say this has no real solutions. Now, sometimes we can solve a quadratic algebraically by just taking the square roots. And that happens when the b term is 0, or there is no b term. You can solve for x by just taking square roots. So if x squared equals 16, then x is the square root of 16, or positive or -4. So this is an example where there are 2 solutions. That means this quadratic would hit the x-axis at both positive and -4. Some more examples. X squared equals 12. So x is plus or minus radical 12. And if you recall, we could simplify that as plus or minus 2 times 2 times 3. And since we have 2 2's, we can pull that out, and we have plus or minus 2 radical 3. 3x squared equals 27. We would divide by 3. Then we'd take the square root and get plus or minus 3. Another example, x squared minus 25 equals 0. So here's a standard form quadratic where there is no b term, just an a is 1 and your b is your c is -25. We would add 25 to both sides, take the square root, and get plus or minus 5. In a situation where we have x squared plus 25 equals 0, we would subtract 25 from both sides, take the square root, and we can't take the square root of a negative number, which if you connect this to what the graph might look like, what does this look like? Well, this would simply be the parent function shifted way up 25, and so that you can tell that it never hits the x-axis. Okay, here are some examples for you to try. X squared equals 5. I'll go ahead and put them all on the screen, and then you can pause it and give these a shot. Okay, to solve the first one, I would simply take the square root of both sides, so it would be plus or minus the square root of 5. In the second case, I'd subtract 10 from both sides. X squared equals negative 10. X is the square root of negative 10, which I can't do, so that would be no real solutions. If you can make this connection, this is shifted up 10, so it's not going to hit the x-axis because I have a positive a value. So there's no real solutions in this case. First one there. Okay, so I would add 12 to both sides. In the third case, 2x squared equals 12. Divide by 2. Take the square root, plus or minus the square root of 6. In the last case, subtract 30. Divide by negative 5. And again, x equals plus or minus the square root of 6. Thanks for watching, and see you in class.